In this module, students explore materials and their properties. They also investigate manufacturing processes for forming plastics, woods, and metals into products. Using a desktop injection moulding machine, students work through a series of exciting hands-on projects involving the moulding of thermoplastics. A fully functional simulation of injection moulding enables you to turn every PC into a plastics injection moulding machine. This means that you only need one hardware system in the classroom for group demonstrations and team problem-solving tasks. Students configure moulds, follow machine operating procedures, and observe mould flashing and shrinkage associated with poor design and processing techniques. This module also includes VMAT, our unique PC-based virtual materials tester. Sitting at their computer, students select materials and in turn test their properties using industry-recognised machines. Realistic results are presented for the learner to compare and contrast different materials. They also consider materials best suited to practical applications. For example, testing materials for density and tensile strength. Their strength to weight ratios are calculated, and the most suitable material is selected for an aircraft frame. The well-written, ready-made lessons supplied with this module help tutors introduce topics and allow students to go on and carry out tasks, independently and within teams. The learning content is designed for flexible delivery from a PC, server system or internet connection. Its HTML format meets the requirements of the SCORM standard for access on a virtual learning platform. It includes continuous and summative assessment for automatically tracking and marking students' progress. Theory presentations in PowerPoint are used by tutors to introduce topics and cover key concepts. When used with a student response system, automatic tracking of the integrated questions and instant feedback helps engage and excite the students. This also saves valuable tutor time with automatic marking and reporting. Taking a product from concept stage through to manufacture is a challenge for the most experienced team. The 9-stage design loop is a systematic approach explored by students. In the final task, students are given a brief from a client to develop and make a doorknob for a cabinet. They are required to meet user criteria, and the manufacturing costs must be considered. The module is fully resourced with moulds so that different parts can be manufactured in quantity. Examples include a multi-part mould, tokens and extrusions that fit together to form products. A unique smart mould has multiple configuration options enabling different parts to be produced. Examples include corn cob holder, screwdriver with metal insert, door handles with various fixing options. This unique mould configuration system is integral to the injection moulder simulator, enabling students to investigate designs just like using the real machine. Support materials are available for tutors to set a manufacturing project. Based around the mass production of golf tees, students work as a team to configure and make a 2-part mould using CNC technology. Once made, the mould is then used to mass produce plastic golf tees. Within the activities, students realise various scientific concepts. They also perform mathematical calculations in the context of real engineering systems. This approach makes the ST350 a great application for a STEM programme.